Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VQ syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also, click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 32, which is based on automatic cylinder reciprocating system. Now, cylinders can be made to reciprocate automatically without the interference of human being for operating the valves. This can be achieved by using two different techniques. One is called as two sequence valves and another one is called as solenoid operated directional control valve and limit switches. Out of which we'll discuss the first option, which is based on using two sequence valve. This consists of two sequence valves SV1 and SV2 in parallel with two check valves CV1 and CV2 respectively. Both connected to a hydraulically operated 4 by 2 pilot operated direction control valves, which shows the circuit diagram. Now in circuit diagram, C refers to double acting cylinder, SV refers to sequence valve, CV refers to check valve, R refers to relief valve, T refers to tank, F refers to filter, D refers to two position 4-way pilot operated DC valve, P2 is nothing but second position of valve and P1 is nothing but first position of valve. And how does it work? Let us understand. For position P2 of a DCV, the cylinder retracts and at the end of retraction, pressure build up in the rod end side and this is sensed by SV2. Each check valve and the corresponding pilot line does not allow the shifting of the four-way valve until the particular stroke of the cylinder is completed. Check valve is necessary to allow pilot oil to leave either end of DCV while pilot pressure is applied on the other end. This permits the spool of DCV shifted to position P1 and the extension of the cylinder take place and at the end of extension pressure builds up on the piston side which is sensed by SP1 and the cycle continues and hence the reciprocation continues. And the other technique which is used is called as using solenoid operated DCV and limit switches. The respective figure shows that one. This consists of a 4 by 2 solenoid valve operated by DCV, that is directional control valve, which gets energized and de-energized with the help of two limit switches which senses the end of stroke. Energizing and de-energizing of the solenoid changes the direction of flow into the pilot, which changes the position of 4 by 2 pilot operated DC valve and the corresponding extension and retraction of the cylinder take place in this and continues until the pump is shut off. The limit switches 1 and 2 will alternatively energize and de-energize solenoid, thereby charging the direction of fluid flow into the pilot. And the respective block diagram was being represented in the right hand side of the slide, where capital C represents double acting cylinder, P represents pump, R represents relief valve, T represents tank, F represents filter, D1 represents two position 4-way pilot operated DC valve and D2 represent two position 4-way mechanical operated DCV and P1 is nothing but the positions of the valves. Next, coming to the concept called as a locked cylinder using pilot operated check valve. Holding the cylinder in exact desired position under heavy load is called locking off cylinder and a cylinder so held is called locked cylinder. Whenever a heavy load is to be precisely positioned at any desired point, oil leakage through the direction control will allow the cylinder to drift out of the position. One of the methods to prevent the cylinder drifting from the desired position is to make the direction control valve leak proof, which is an ideal case. Another method of holding the cylinder exactly in the desired position is by using a pilot operated check valve in the return line of the cylinder before the DC valve. This will prevent the drifting from its exact intended position even though there is a leakage in the DC valve, and the respective figure has been shown on the left hand side of the slide. Now, the hydraulic circuit of a cylinder using check valve and a 5 by 3 DC valve is shown here. Now, how it is going to work? The pilot operated check valve, that is CV1, holds the load and prevents the cylinder from drifting and retracting until the head end of the cylinder is pressurized. However, the cylinder is not locked for extension and hence it can be extended. Return line check valve CV2 provides the back pressure to load and counterbalances it. Then coming to the next concept, that is called as a locking of both extension and retraction of the cylinder. It is possible to lock the cylinder both for extension and retraction by blocking flow into and out of the cylinder. Two pilot operated check valves are used. Now figure at the middle in the slide shows the required hydraulic circuit. The load is locked as long as the cylinder seals remains effective and neither of the lines to the cylinder are pressurized. Other applications of check valves are a check valve in output line of a pump prevents the draining of a fluid from the pump when the pump is stopped, thus keeping the pump primed. This is especially important when the pump is above the reservoir. That is, when the suction is high, the spring rate should be low to ensure smooth inlet flow, which you can see on the right hand side of the figure represented by the letter A, which is called as input line. In the same fashion, a check valve in the output line refers to the B, prevents the system oil flowing back into the pump, and a check valve in the return line provides the counterbalancing effect on the actuator load, which you can see in the figure C. So this is about the concept of locking of the cylinder. So by this, the time limit reaching for the session, and henceforth we are going to stop the session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay.